Nations like India and China have already populated the moon with robotic rovers and landers, providing us with a high-fidelity map of the lunar surface. NASA's Artemis 1 mission confirmed the hardware side of the equation. The Orion capsule successfully orbited the moon and returned to Earth autonomously, without a single person on board. However, there's a distinct gap between a machine flying a pre-programmed route and one that must keep humans alive in the vacuum of space. NASA has historically struggled with a bespoke launch culture, treating its rockets like delicate works of art. As Jared Isaacman noted, launching a complex system like the SLS only once every 3 years makes it difficult to build a reliable, professional program. To hit the 2028 landing goal, NASA has to move past these isolated experiments and establish a consistent industrial pipeline of launches. Artemis 2 is the specific pivot point for that transition. It's designed to test the systems required for a sustained human presence on the Moon and, eventually, Mars. For the first time in this program, NASA is introducing a volatile element to the machinery, a crew of 4 astronauts. This mission places people inside the Orion capsule to measure exactly how the hardware responds to a living, breathing crew in real time. No computer simulator on Earth can perfectly model the biological chaos of 4 humans living in a closed system. Artemis 2 is the ultimate human-in-the-loop test. On April 1st, the SLS rocket generated 8.8 million pounds of thrust, pushing the crew toward Earth orbit. Engineers describe the ascent as nominal, the standard term for a flight going exactly to plan. The Orion capsule fired its main engine for 6 minutes. This translunar injection burn placed the spacecraft on a looping trajectory toward the Moon. The math was so accurate that Mission Control canceled 2 of 3 planned course corrections. The propulsion hardware worked as designed, but the rocket was only half of the trial. Once the engines cut out, the focus shifted from the vacuum of space to the interior of the capsule. Humans are a burden on a spacecraft. They consume oxygen, they exhale CO2, they generate heat, and produce waste. These biological needs immediately stressed the machinery. The crew dealt with a water dispenser failure and a minor loss of redundancy in the helium systems, small technical issues that only arise when people are actually using the gear. Engineers used the crew as test subjects, ordering back-to-back exercise sessions to deliberately increase the CO2 levels in the cabin. They needed to know if the scrubbers could handle the physical exertion of a human crew. Resolving these anomalies in a 10-day orbit is the only way to build the safety case for future years-long missions to the Red Planet. During their flyby, the crew broke the deep space distance record set by the Apollo 13 mission over 50 years ago. During a transit of the lunar far side, the crew shared an unscripted moment, naming a bright crater Carol in honor of Commander Reed Wiseman's late wife. While robotic probes provide mineral data, human crews provide cultural context. These moments turn technical milestones into something the public can actually relate to. The success of the lunar flyby is significant, but the mission remains unfinished until the crew returns home. The Orion capsule will hit Earth's atmosphere at 25,000 miles per hour, subjecting the hardware to temperatures and pressures impossible to fully replicate in simulators. This is a critical test. After the uncrewed Artemis 1 flight, NASA discovered unexpected damage to the heat shield, which delayed this mission for more than a year while engineers investigated the cause. The outcome of this re-entry will determine if the current design is safe enough to carry humans on the next phase of exploration. A successful splashdown moves the Artemis program away from one-off test flights and toward a sequence of recurring annual launches to the lunar surface. This operational cadence is what allows NASA to begin integrating larger pieces of the puzzle, like the massive commercial landing systems being developed by SpaceX and Blue Origin. Artemis 2 isn't just a record-breaking flight. It provides the performance data needed to certify that these life support systems can sustain human life for the much longer journeys ahead.